This is Pre-AP Pre-Calculus Notes section 1.1. We're on part 3 of 3, so this will be the last part of this notes. Most of our notes are not this big. This has taken quite some time. Graph the following piecewise defined functions on the grid provided. State the domain and range. So we got a few things we got to do here. We are supposed to graph, which is no easy task, and then we have to state both the domain and range. So looking at number 1, let's identify what each of these graphs are. This is a parabola. This is a line. We're supposed to graph this parabola, but instead of the whole thing, we're supposed to go from -1 to 4. So that means from here to here, we're supposed to graph this parabola. And we're supposed to include 4. We're supposed to get really close to -1, but not actually touch -1. That's what's happening here. And we're supposed to graph this line to the right of 4. So that means over here, we are supposed to graph that linear part of the function, 2/3 x plus 2. Now, there's different ways to do this. I will likely show you different ways to do this. But as long as you do it correct, the methodology that you use is not all that important to me. What I would suggest for a parabola is first find the vertex. This vertex is normally 0, 0. This is going to the right 2 and down 2, or down 3. So that means the vertex is at 2, -3. Is that included in the domain? Yes, because 2 is between -1 and 4. So let me graph the vertex, which is to the right 2 and down 3. Just going to label that. And then from here, the only thing that this graph had going for it was the translations, right 2 and down 3. There is no reflections, there is no dilations. So for a parabola, if we go to the right one and we square it, we're going to go up 1. So we put a dot. If we go right 2 and we square it, we're going to go up 4. 1, 2, 3, 4. Now this dot here, it's going to go there. Should it be opened or closed? Well, this says x is less than or equal to 4. Equal to means closed. So the right part of this looks like this. If we go left, -1 squared is 1. -2 squared is 4. And then -3, 1, 2, 3 squared is 9. So I go up 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to put an open circle there because it says when you get to -1, you do not include it. Now the reason that we don't go any further than this, we don't go 4 to the left and up 16, because the domain doesn't go past -1. We don't go to the right 4 or to the right 3 and up 9, because the domain does not include anything bigger than 4. So this blue that you see here is the parabola, and it is graphed from -1 to 4. Now we're supposed to graph this line. Now what I would suggest is, there's lots of ways to do this. Normally I would say start with the y-intercept. Well, that y-intercept is here, and our graph is just to the right of 4. So the y-intercept is not actually a part of this graph, this ray. So I'm just going to pick a random number to put in for x, and this random number is bigger than 4. I want to choose this number wisely. So for example, say that I choose to put the number 5 in. 5 is not a great number because 2 times 5 is 10. 10 divided by 3, that's a decimal. I want to put a number in for x that's bigger than 4, that if I divide it by 3, it goes evenly. So for example, let's say that I was going to put a 6 in. So it's going to be 2/3 times 6 plus 2. 2 times 6 is 12, divided by 3 is 4. That's 4 plus 2, that's 6. So we're going to have the ordered pair 6, 6 on this. That's not the beginning of the graph or the end. That's just a point on it. Then I'm going to use the slope since it's a line. From this point, I go up 2 and to the right 3. Put a dot. I go up 2 to the right 3. Put a dot. I go left 2. Pardon me. I go down 2 and to the left 3. If I do that, I go off of my graph. So I'm going to connect these points with a line segment, knowing that when I hit 4, it's supposed to be an open circle. So I'm going to put an open circle there. If you wish to know the coordinates of this point, all you would do is you would take 4 and you'd put it in here for x. 4 times 2 is 8. And then we divide 8 by 3. That's not pleasant. 8 divided by 3 is going to be 2.6. Add 2 to that. We're going to get 4.6, I believe. I just got moved out of the room that I was making this video in. So anyhow, what was I saying? So 2 times 4 is 8. 3 goes into 8 2 times. And it'd be 0.6 left over. So it would be 2.6. Add 2 to it is 4.6. So this should be hitting here 1, 2, 3, 4.6. Looks like that's what's happening. You could put that ordered pair there. And if I insist that you do that on a test, then you should do that. Let's check out number 2. Just 1 second, I got displaced again. All right, number 2 is a little simpler because they're lines, they're linear. Well, I guess there's an absolute value in here. Oh, we didn't finish number 1. State the domain and the range. Domain, what can you put in for the x values? Well, the domain starts at -1, goes to 4, it includes 4, and then it goes to the right. So the domain is going to be not including -1, going to the right forever. That's a -1 to infinity. The range, better look at the graph to find that. The lowest the y value gets is -3. It includes it. So that's a bracket. And then it goes up to 1, continues to go up past 1, goes up to 6 and stops, but this one here stops below 6. So in essence, our y values are going to go up from -3 to infinity. Infinity is not a number, so we always say a parenthesis around that. Let's check out number 2. This is an absolute value function. Its vertex is -2, 1. This is just the number with a number. This is just an ordered pair. So this is an ordered pair, a point at -1, 3. And this is another line, just like we had on the previous problem. Let's start with the most easiest thing, which is this point. We have a point at -1, 3. That's easy. Now, let's see if we can get the rest of this graph on here. This vertex is at -2, 1. Is that included in the domain? -2 is less than -1. So at -2, 1, I'm going to put a point. Let me change this color for viewing pleasure. Let's make this red. So at -2, 1, we got the vertex. Nothing else about this graph has changed. There is no reflections. There is no dilations. So the slope of the absolute value function is 1 and -1. So if we go to the right, we go up 1. If we go to the left, we go down 1. So when I go to the right and up 1, that lands on the boundary. Let me do something different on this one. I'm going to graph this black. I'll end up getting rid of this. This is a boundary of the graphs at -1. That's the only boundary that this graph has. It's at -1 because it's to the left of -1, it's at -1, and it's to the right of -1. So to the left, we're going to graph this absolute value. Slope here is 1. It's an open circle because it does not include it. As we go left, the slope is -1, and it goes forever. So I put an arrow on it. This next one, this is a line. Now, the y-intercept for this line is actually included in this graph. It's at 5. It's going to make a note. Y-intercept is at 5. So that means this is crossing the y-axis at 5. Now from there, I can use the slope to find other points. I go down 1 to the right 2. 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 When I get over here, I'm going to go up 1 to the left 2. That's too far. Instead, I'm going to go up a half and left 1. Supposed to be an open circle there. Open circle because it says greater than but not equal to. Connect those points using my company issued straight edge. And this, we have graphed this piecewise function. This is an absolute value. This is an ordered pair. And this is a ray that's part of a line. What's the domain of this fella? Well, it looks like it starts all the way from -infinity. It includes every number from left to right. Some hairy things happen here, but -1 is accounted for, so the domain is all real numbers, or you could say -infinity to infinity. Range, this goes down forever, and it goes up forever, and everything that's here in between is accounted for all the y values, so the range is also -infinity to infinity. All right, number 3, we have an absolute value function, a square root function and a square root function, 2 of those, and then we have this ordered pair. Let's do this ordered pair first. That's easy. There's a point at 2, 0. So 2, 0, I put a dot. That's done. And I did that wrong. I apologize. X is 0, Y is 2. It should be 0, 2, not 2, 0. Now, anytime I make a mistake like that, I like to look at the previous problem, see if I made the same mistake on the previous one. -1 is X, Y is 3. I did not. Freak accident. What's the vertex of this fella right here? The vertex would be 0, 3. Let me change this color. So at 0, 3, we're going to have an open circle. It's open because when X is 0, it does not include it. And then, how does this negative affect the graph? That's a horizontal reflection. So instead of this going like this, it's now going to go this way. And this 3 translated it up 3. We already got that taken care of. That's why this vertex is here. So for the square root, we normally go right 1, up 1. Since it's reflected horizontally, it's left 1, up 1. Put a dot. And we're going to keep going until we get to -4. Now if we go left 4, 1, 2, 3, 4, and we go up 2, because the square root of 4 is 2. It's going to put us here. That's a closed dot, because it says x is greater than or equal to negative 4. So it stops right there. This represents this part of this square root function. Now this bottom square root function, it has a vertex of 0, 3. It's also not including the 0. So that's right over top of this other red one that you saw there. The color doesn't matter, I'm just showing you that it's overlapping. Nothing else has changed about this. It's just already been translated up 3 with the vertex. So this normally goes right 1, up 1. That's how it's going to be here too. It's going to go right 4, 1, 2, 3, 4, and up 2. How do I know right 4 and up 2? Because the square root of 4 is 2. I can go to the right 9 and up 3 because the square root of 9 is 3. This domain goes to the right forever, so it looks like so. That is the finished product. What's the domain of this? Well, the domain, every x value to the left, to the right of negative 4 is accounted for, including negative 4. As far as the range goes, this gets a little tricky. The range starts at 2. And then it jumps. So it's just a random 2, and then it starts at just above 3, and it goes up forever. It doesn't include 3. That's why I'm using parentheses. It goes from 3 to infinity. Last one, number 4. We got more of these square roots. So I hate this. I want the coefficient of x to be 1. So I'm going to rewrite this as the square root of a negative x plus 2 plus 2. This vertex is at negative 2, positive 2. This vertex is at positive 1, negative 4. This is a line. Let's do the line first because that's typically the easiest. Is this y-intercept of negative 2 including the domain? Well, for this to be included, the x value of 0 has to be included in this, and it is. So I'm going to graph this line with the y-intercept first. Y-intercept is negative 2. Then I'm going to use the slope to find other points, so I run out of space. So slope of negative 2, if I go down 2 and to the right 1, it puts me here. That's the end of where I'm supposed to go, because I'm supposed to go to 1, stop. And then if I go left 2 and up 1, and left 2 and up 1, and once again, when I get to this here, I need to stop. It's an open circle. It does not include negative 2. This is a segment with open endpoints. It's part of a line. Let's graph this one next. Vertex negative 2, 2 is kind of included in this, but it kind of isn't. It's an open circle at negative 2. So at negative 2, 2, I have this open circle over top of the other open circle. You don't need to draw it twice. I'm just doing it so you can see what's up. Once we're there, once we have that vertex, we've already translated left 2 and up 2. Now this is going to be a horizontal reflection. So normally this goes like this. Horizontal reflection, it's going to go like this. Scale hasn't changed, so I go left 1, up 1. Square root of 1 is 1. I go left 4, 1, 2, 3, 4, and up 2. Square root of 4 is 2. I go left 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and up 3 because the square root of 9 is 3. This continues to go left forever because the domain for this orange part is everything to the left of negative 2. This last one, we have a vertex at 1, negative 4, does not include the 1. That's right, whoops, that's right over top of the previous endpoint of that segment. So we've already taken into account the positive 1, negative 4, the translating right and down 4. What we haven't taken into account is this vertical reflection. So normally the graph would look like this. Vertical reflection is going to look like this. Normally you go up to the right 1, up 1, we're going to go down 1. Normally you go to the right 4, 1, 2, 3, 4, and up 2, we're going to go down 2. This goes to the right forever. I'm going to go to run out of space. I'm going to go to the right 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then down 3. I think that put me here. That is graphed. The domain for this is nuts. The domain starts at negative infinity, and then it jumps over negative 2. Then it goes to positive 1, it jumps over it, and goes to infinity. So our domain is going to be negative infinity to negative 1, jumps over negative 1. I'm sorry, that's a negative 2. Jumps over negative 2 and goes to positive 1. Jumps over 1 and goes to infinity. In other words, all real numbers except for negative 2 and 1. The range does something similar. It goes from negative infinity and skips over negative 4, skips over 2, and goes to infinity. So it's going to go negative infinity to negative 4, skips over negative 4, goes to 2, skips over 2, and goes to infinity. In other words, the range is all real numbers except for negative 4 and positive 2. Finally, that concludes the first notes for pre-calculus. Please do the assignment that you are supposed to do according to the website.